Hello everyone. In this video we're going to be solving an interesting exponential equation. We have I to the power x equals 2 and we're going to be solving for x values. I'm going to go ahead and show you the solution method and then we're going to check our work and we're going to talk about a couple different things. So this is kind of like a complex exponential, so we got to be careful because a complex number when expressed in polar form may have multiple values. There are infinitely many branches basically of a complex number. So we have I to the power x equals 2. What we're going to do is we're going to express this in polar form. We're also going to be taking a look at a result from Wolfram Alpha to compare to our answers. All right, great. So let's go ahead and start by writing I, which is the base, in polar form. To be able to write I in polar form, I'd like to write it in standard form first. So I can be written as 0 plus 1i, which means that 0, 1 basically represents I on the coordinate plane, on the complex plane, where imaginary axis is this one and real axis is this one. Okay? Of course, we also have to consider another thing here, which is the modulus, the distance from 0. For I, it is going to be 1, because this is just the same point as 0, 1, but this number is basically representing I here. So R equals 1, and theta is the angle that the number makes with the x-axis, and that is going to be pi over 2 in this case. Okay, so we do need two things, R and theta. That's what we need. We can go ahead and now write our number z in the form R times e to the power I theta. But since our number has R1, we don't have to worry about it. So I, which basically replaces z here, can be written as e to the power I times pi over 2. Now, here's one question that comes up. Do we really need to worry about different branches of I here? In my opinion, we don't, because we're going to raise I to the power x, and that's going to equal 2. As long as we can make sure that x covers pretty much all values so that this always equals 2, we should be good. If you don't agree, please let me know and we'll talk about it. Anyways, so I can be written like this, which is kind of nice, and I has itself in the exponent, so that's kind of funny. But anyways, we can go ahead, and this, by the way, this formula or identity, whatever you want to call this, can also be used to evaluate I over I, which I made a separate video about. You can also check that out. Anyway, so we were able to write I. Let's go ahead and raise it to the power x. So that's going to be I to the power x. And we're going to set it equal to 2. But let's also go ahead and write 2 in polar form. To be able to write 2 in polar form, we're going to write it like this. 2 can be written as 2 times 1, and 1 can be written as e to the power I times 2 and pi. In other words, if you consider multiples of 2 pi, that's basically going to represent 0 radians, or 2 pi radians, or 4 pi radians. Basically, all multiples of 2 pi are going to bring you to the exact same point. Make sense? And obviously, the modulus is going to be 2 because it's absolute value. That's it. So we can go ahead and replace this with, replace the 2 with 2 times e to the power I times 2 and pi. Let's go ahead and do it. And then we're going to simplify this expression. Let's go ahead and get rid of all the I to the x and 2 and multiply these together. So we can kind of write this as pi over 2 x times pi over 2 times I equals 2 times e to the power 2 and pi I. I just wanted to write the I at the end. Doesn't matter, no big deal, but let's go ahead and do it. Obviously, I doesn't cancel out because 2 doesn't have an I in it. The exponent is 1, so we need to use logarithms here. And for this purpose, I'm going to use the natural log, which is ln. So let's go ahead and ln both sides. And if we do, we're going to go ahead and get rid of all the exponents that are causing the trouble. So we have ln this equals ln that. Okay? Obviously, you could also write it a little differently. Don't write this as 2 and pi, but add it later. Same thing, because it's going to turn into 2 and pi I. So ln is going to bring down the exponents. So this is going to be x times pi over 2i And the right hand side, we kind of need to think about the log of a product. So we can write it as the sum of two logs, ln 2 plus ln e to the power 2n pi I. But again, this we can bring to the front, and this is going to be x times pi over 2i equals ln 2 plus 2n pi I. Awesome. Now, we got rid of all the exponents, so it's kind of nice. We want to solve for x, so it would make sense if we divide both sides by pi over 2i. Let's go ahead and do it. X equals ln 2 plus 2n pi I divided by pi I over 2. By the way, I forgot to mention that n is going to be an integer. N is an integer. Okay? Great. Because we're talking about multiples of 2 pi. So this 2, when flipped, is going to go to the top, and it's going to be 2 ln 2 plus 4n pi I divided by pi I. Okay, we got rid of the 2, but we need to get rid of the I as well. You don't want the I at the bottom. You kind of need to get rid of the I, because something like 1 over I or 2 over I doesn't make much sense. We want to have a multiple of I. So, or we want I in the numerator. Make sense? I hope it does. And for that purpose, we're going to multiply the top and the bottom by negative I. Let's go ahead and do it. And we're going to distribute. When we distribute, and why not I but negative I? Because we have to multiply by the conjugate. And also, if you multiply I by negative I, you get negative I squared, which is equal to positive 1. Because by definition, remember, I hope you know this, I squared is always negative 1. That's actually the definition of I, the imaginary unit. Okay? So, let's see what we get from here. When we distribute the negative I, this is going to be negative 2 ln 2 times I. And then I times negative I is going to be negative I squared, which is going to be a positive 1. So we can basically write this as plus 4n pi. I got rid of, we got rid of the I because I times I is I squared. And all of that is divided by pi. Because at the bottom we only have pi. Make sense? So far so good. Okay. Now, this answer, you can kind of plug it in and find that it verifies. So here's what we can do. And also, I'm going to show you something. Let's go ahead and write it like this, which looks a little better. And then let's go ahead and separate it. Since this is kind of like a difference of two fractions, we can go ahead and split it into two fractions like this, right? And then the pi cancels out and we end up with 4n. Now this is significant. Let me go ahead and write it like this. Negative 2 ln 2 I over pi. And then I just want to add plus 4n. I'll tell you what is going on with the 4n, but let's go ahead and focus on this first. I want to go ahead and take this part and plug into I. So I to the power x is going to be I to the power this, but let's replace I with e to the power pi over 2, and then raise it to the power negative 2 ln 2 times I over pi. Pi is going to cancel out. I times I is negative I squared. I mean, I squared equals negative 1, so that's going to cancel out. That's going to cancel out, and that's going to cancel out. We're going to end up with, and the 2 is going to cancel out, and we end up with e to the power ln 2, which is actually equal to 2. But what is going on here? I totally forgot about this, and the answer is still correct. Let me tell you what is going on. When you go ahead and raise I to the power x, and you had this piece, e to the power something, plus 4n, and now you can write it as e to the power something times e to the power ln 4n. And basically, so here's what is going on. To keep a long story short, this 4n, when you raise it to the power I, in other words, when you get I to the power 4n, it's just going to be I to the power 4 to the power n, which is 1 to the power n, which is 1. So that's not going to change the answer, but we still have to have it there because we have to find all the solutions. Okay, great. Let's go ahead and take a look at the result from Wolfram Alpha, which is going to agree with what we found. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.